Okay, so here we have a right tail test where we are told that H naught is that the population parameter is p equals 0.8, and the alternative hypothesis is that it is greater than 0.8. We have apparently a simple random sample of size 200 with x being 165. We're testing at the significance level of alpha equals 0.1, i.e. 10%. Okay, so first off, we need to calculate what p hat will equal. That's going to be the 165 divided by the 200, so 0.825. Just because that sample proportion is larger than 0.8 is not enough. We need to take into consideration how the sampling distribution is spread out. So, remind you of the formula here. I'm going to be putting in 0.825 for p hat, and then 0.8 everywhere else except for n. N is 200. Let's see what we get there. Now the calculator knows the order of operations. So if we put some careful use of parentheses around the subtraction in the numerator, and then divide by square root of, okay, we would have 0.8 times 1 minus 0.8 divided by the 200, and then close the parentheses so that it knows that what's underneath the square root, that is done. And it is asking us to round to 2 decimal places. That makes sense for using the table. All right, so that was going to, we've got a 3 in the thousands place, one place after the hundreds. So that's going to round down to 0.88. Identify the p-value. Okay, so although we have the table, I want to show you something else here. What is the probability if the null hypothesis is true? If the population parameter really is 0.8, what is the probability we would have come up with this sample where we're getting a z-score of 0.88? It accepted 0.88. Okay, so because we've calculated a z-score, we have standardized this. We would be going from 0.88 infinitely to the right, so using 10 to the 99 for the largest number going towards positive infinity. And that would give us a 0.189 if we rounded down. But we are given the table. So let's see here. If I look up 0.88, I'm seeing 0.8106. The difference between what I just did with normal CDF and this is that the table is set up for going to the left, not to the right. And so now we're seeing something pretty close. That's going to round down to 0.189. And because that is larger than 0.1, here's what happened. That z-score was not extreme enough to get us up into the top 10% or an area of 0.10. It's not in the critical region. And so our probability of 0.189 is greater than the alpha of 0.1, which, by the way, that's the same as 0.100. Therefore, because P is greater than alpha, we fail to reject H naught. We have not brought statistically significant evidence or sufficient evidence. We have not brought that evidence to show that P is greater than 0.8. Do not reject the null hypothesis because the p-value is greater than alpha. Okay, that's it for this particular example. Let's see what else we can do.